All right, so here we go, a little graphing sine and cosine today.
Yep, section 4.4.
Like lines, but with curviness.
Yes. So, I'm going to hit the arrow.
Arrow it is.
All right, the big thing that we need to know about sine and cosine curves is that they have this thing called amplitude,
Right.
which is our height here. It's a distance from zero up here to the top.
Top of the wave.
And the same distance should be over here as well, from the middle to the bottom. Those should be equal.
And one cool thing about amplitude is it's always positive. It's a distance from the middle of your wave up and down.
Right, so it's always positive.
Right.
And then the period is going the other direction. What we have is one sine curve, okay, and then after that, like this just keeps going.
Again and again and again.
Yeah, it's what we call oscillating, because it goes up and down, like it goes back and forth, kind of like your fan. You might have a fan that oscillates because it goes back and forth. So it's kind of similar to that. This just keeps going back and forth.
Beauty Queen parade wave, just she oscillates her hand back and forth.
Like that as well. So, yeah, that's what period is. It's just one curve, like we've got for, this would be like a sine function where we've got a hill and a valley, but like this would keep going. That's terrible. I don't even know why I did that.
I don't either.
But it'd keep going forever. It'd keep going back and forth.
So basically what we've got is this general form of a sinusoid, which would be, or sine or cosine. It's a sinusoidal shape, okay? And inside here is just like what we've done with functions since time immemorial. Super secret opposite society on the inside, in case Steve just made the necessary corrections.
Yeah, it's really supposed to be minus.
It's got to be minus, which tells us that we're going to move. If it's minus, we move in the positive direction.
Or
Okay?
if it's negative, we move
To the left. So if it says plus C, we move left. If it says minus C, we move right. Just like what we've talked about in the past. It's no different.
Yeah.
Okay?
But each of these letters, A, B, C, and D, those would be numbers in our actual like situation, and they could, some of them could be zero. We may not see all of these at the same time, and so this.
A will never be zero though. Just
right,
a point of fact.
or it won't be a sine or a
Right.
cosine
Right.
function. It'd just be a zero function.
Right.
Okay, but here it lists out what each of these letters represents to our graph.
And they're all important.
Yes, the absolute value of A is the amplitude. And so we talked about what the amplitude was, but that also tells us the vertical stretch or shrink. Which
Right.
is good to know.
Which is what it does originally with a function.
Right, and when you multiply it by something, it's a vertical stretch or shrink. The B tells us the period, but it does it like secretly.
Right.
Because B is not the period itself.
No.
It's
But 2 pi divided by that.
right. So whatever number's in front of our x or our theta or whatever, we'll divide by that, and that'll give us the period. Also remember that if we have a number here, we take the reciprocal of that, and that tells us the horizontal stretch or shrink.
Right.
So.
And then phase shift is C, and that tells you how much you move left or right, which is what we corrected really quickly up here.
Right.
So it's just fancy language in trig functions, phase shift, okay? It's just
Instead of horizontal.
Instead of horizontal.
It still
it's
means
the
left
same
or right.
thing, yeah.
It has to do with the fact that, like, depending on how far we move, like, we've still got the same basic shape going on. We're just moving it over. The
Right.
phase of it is different.
And we could be in phase if we move far enough that they match.
Right.
Or out of phase if we move far enough that they're exactly opposite.
Yeah. D, vertical shift, that's the shift up or down. That one's.
Just like what it's always has been.
Yeah.
So, given the amplitude and period of the function, graph 2 periods. So let's start simple with sine theta.
Yeah. So if we have this situation, keep in mind that we've got like a 1 and a 1, where this is telling us A and B. So our amplitude here would be 1, and our period, which is the other thing they want us to list, is 2 pi over B.
Right.
2 pi over 1, which is 2 pi.
2 pi. Which means, like, if you use your circle card with a unit circle or whatever way that you do the trig, you're going to have to go out 2 pi units to be able to get one full period of the graph.
Right, so here's how I like to draw it. We have an amplitude of 1, so we need a tick mark up here at 1, tick mark down here at negative 1.
Yep.
Then the period's 2 pi, so we need to be out here at 2 pi. That's where we're going to end our sine curve. Since they want 2 periods, we're going to do a positive and a negative sign.
And here's one period right here. And then if you actually start here and go to 0, that's 2 pi. And then from 0 again forward, that's 2 pi.
Right. So then what we need basically is each of our sine curves needs 4 things. So over here on the right side, let's ignore the left side for now. Over here on the right side, halfway between 0 and 2 pi is pi, and then make another tick mark on either side. So
halfway in between.
So we've got 4 spots here. Because a positive sine curve starts at 0 and then goes up, okay, because it's positive. So at our first tick mark, we need to be up here at 1. Then we're going to come back down to pi, and then we're going to come back down to -1, and then we're going to come back up here. And this is us teaching you how this works. Like, this is a pattern. It just goes back and forth. If we start at 0 and we have to go up, then the next logical thing to do is go down.
So check this out. So if I made a sine chart, maybe, and I said 0,
a table of values.
table of values, that's what I
Yeah.
said, a table of values.
Yeah.
And I set it up exactly like K. Steve has arranged it over there. So this is what I've got, and what we're saying is, if you put 0 in for the sine of theta, and you look at your unit circle information, it's going to be 0. And then when you put pi over 2 in for theta,
What
and
is
you look
sine
at your
of pi
unit
over
circle,
2?
sine of pi over 2 is 1.
Right.
Sine of pi, 0. Sine of 3 pi over 2, -1. Sine of 2 pi, and that's back to 0. By the way, these are coterminal because you're back where you started.
Right.
So basically, what K. Steve has done here is given you this table of values right there.
And because it's a pattern, because it's a pattern every time and it works every time like this, if you need to plug in the values, that's fine, but you may not have to once you get the hang of the pattern.
Right.
But if all else fails, you can always use
You can always look at the
the
values.
table of values
Yeah.
to graph anything.
So negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. We're going to get the exact same graph going the other way.
Right, so if I start here at 0, I have to go down.
Got to go down first. Got to completely do it.
Middle, top, middle.
Bam!
That's 2 sine curves right there. 2
There you go.
periods.
That's a great looking sine curve.
Well, thank you.
Yeah, you're welcome.
Cosine is mostly the same. Like, the amplitude is the same, the period is the same. There's just going to be a little bit of change going on here. So
Leave that there just in case.
A is 1, E is 2 pi. Okay, because the fact that these are 1s means the same thing that it did before. So when we graph this, we have the same tick marks because we have all the same important values, but it's not going to look the exact same because we start someplace different.
So think about that starting place. What you're going to do is you're going to take 0 and put it into the cosine function.
So cosine of 0 is
1. Bam.
So
that's where you're going to start. And then go to the next tick mark, which is going to be pi over 2. Cosine of pi over 2, 0. And again, use your unit circle information to help you get all this organized out.
And so again, it's a pattern. We started at the top, so then we have to go to the middle on the left and the right. Then we go down to the bottom, and then we come back up, and then we go back up again. So we've got this pattern.
There you go. And notice how it is really, really similar to the sine curve. It's almost the same exact thing, except perhaps there's been a phase shift between them.
Right. And if you pause if you're not done copying down cosine theta and then keep going here in a second. If you look at this part of this curve from 0 to 2 pi, and you look at this part of this curve, I should put it in color, from negative pi over 2 to 3 pi over 2, those should look the exact same.
Identical, right?
Minus the
minus the pi over 2.
Well, yes, minusing the pi over 2. I meant minus the fact that it's not perfectly drawn.
Oh.
It may look a little different because of how good at drawing.
Right.
You may have.
Because you're an excellent artiste.
Yeah. Well,
Oh boy, that says negative sine pi.
So think about if I have negative square root of x, what does that do to my function?
So instead of being square root of x, it becomes square root of x.
And so that's a reflection across the x-axis.
Over the x-axis, yep.
Same thing happens here. So what you could do is real quick go back to your example 1 and think about if we flip this over the x-axis, what happens? Okay.
Where you had your peaks, you now got your valleys, and where you had your valleys, you now got your peaks.
Right. So sine theta starts at 0 and goes up first. Negative sine theta, go ahead. Negative sine theta starts at 0 and goes down first. Otherwise, all the rest of the stuff is the same. Still an amplitude Why is that? I don't know. Never mind. Still an amplitude of 1, negative 1, 2
Good
pi.
recovery, good recovery.
Negative 2 pi.
And while you're graphing these, you might notice that what K-Steve has done here has taken the period and basically divided it into 4s. And why? Because if you look at your unit circle, we get pretty numbers on those 4s. We get a pretty number at 0, at pi over 2, at pi, at 3 pi over 2, and at 2 pi for both the sine and cosine. We get perfect numbers, 0s, 1s, and negative 1s.
Right.
Makes it easy to graph.
Right.
We just need to understand what's going on in between.
Yeah, pi over 3, I mean, we could make a tick mark for pi over 3 and then graph it, but that's got square roots and stuff.
Right.
Nobody needs that.
Nobody needs that. Ain't nobody got time for that.
No. So a negative sign starts in the middle and goes down first.
Right.
And then comes back up. That's the difference.
And you can make a table of values again and just plug in. What is the sign at 0? We should know. What is the sign, though, at negative pi over 2? Like, you should be able to find that using your circle, your unit circle. So here you go. Here's your graph. And it's the exact same thing. If you'll look, it's the exact same thing, except instead of being up, it's now down. And that's the only difference. Ready? Hand is quicker than the eye. Here we go. Bam. Look at there. See the difference? See the difference? One more time. Ready? See it? Do you see it?
Yeah, I see it.
Okay, here we go.
All right, so negative cosine. Same kind of thing. You can look at your previous cosine curve we did and just think about for a second before you try graphing it. Think about what you think it should look like if we flip it.
Peaks and valleys and all that. Or make a table of values again. Divide your period into 4, so that would be pi over 2s.
All right, so negative cosine, a normal cosine starts at the top, but we're reflecting it across the x-axis.
Bam.
So
Start
we're
at
going to
0.
start at the bottom, and now we're here.
And now we have to go up. And then we go all the way up to 1 because it's periodic and it has these different rules.
It has this pattern of going up and then down.
And it
It's
goes
almost like
through.
a zigzag, but it's a curvy zigzag.
Yeah, it's a curvy zigzag. It's a cute zigzag.
I don't know. Some people might draw cute zigzags that are not curvy.
So there you go. The exact same thing in both ways.
Now let's make it more interesting.
Okay,
These
let's
are
do
kind
it.
of boring now that we know how to do
Yeah,
them.
boring.
Yeah.
This
Now
is like
let's-
eating Cheetos on Friday. Just not exciting.
Anyway, yeah.
Wow, there's a 2 in front of the theta.
There's also a 4 in front of the
Wow,
sign.
there's a 4 in front of the sign.
So why don't you tell us what that means?
So here's what we're going to do. We're going to talk about amplitude, which on this guy is going to be 4, which tells us then we're going to go up 4 and down 4 when we graph it. So if I start to graph that guy, it's important that I know that now I'm going up to 4 and down to negative 4. Okay?
Right.
Second thing is then that my period now is going to be 2 pi over b, which is that number in front of the in front of the theta.
Right, and one thing I didn't do and our book doesn't always do is keep in mind we're saying sine of 2 theta, and so that 2 is definitely inside of our function, so that's why it's what b is, and that's a horizontal shrink of 1/2.
Right, which
because
means
this is
then
2.
that it's going to get squeezed in a little bit.
Right. And
So
if you think about what's going on, normally it's 2 pi and we're shrinking it into pi.
we got to get the whole curve into pi.
Okay.
So that means then that by the time I get out here to pi, I've completed my curve 1 time. Same thing if I go to negative pi, I've completed my curve 1 whole time. So what does that mean? Think about what we just did. We kind of divided this thing up into 4, so I would be like at halfway at pi over 2, and then at halfway again at pi over 4. Now we did this just a second ago, and
3 pi over 4.
3 pi over 4, that's what I put. So we got these guys. Now, we're going to take the exact same steps. I'm dealing with the sine. The sine always starts at
The middle.
the middle every
and if
single
it's
time.
positive, it goes up first.
So it's going to start here,
Middle.
and it's going to go up first. So
at pi over 4, it needs to be
it's
at the
going to
top.
go all the way up to the top.
And at pi over 2, it needs to be
Pi
back
over
in
2
the
is
middle.
here.
And at 3 pi over 4, it
It's
needs
following
to
the
be
same
in
pattern, the exact same pattern that we took graphing it regularly.
Right.
We figured out what the period was and divided it into half and then half again.
Right.
So the same thing going the other way. So we're going to do half C's, half C's, half C's. And then when I graph, what color did I have? So now instead of going up, I'm going to go down because it's got to match the pattern. It's all about the pattern. So
And then
now
connect your dots in a curvular fashion.
curvular, and it'll be a little bit more tricky on this guy. And there you go. And notice, if we go out here to 2 pi, it's going to repeat
a whole new
deal again.
Okay, so one thing to keep in mind on this is that, like, we didn't really necessarily make a big deal about our scaling here. So your example here could look almost identical to a previous example depending on how big you made the 4 and how big you made the pi.
But we labeled it all correctly.
Which is what matters. The labels are so important here.
I was just going to write down, if you need to see this part, what my x's and y's were. We actually went 0, and then we went all the way to pi, and then I cut that in half.
Made it pi over 2.
And then I cut that in half. So...
yeah, so if you were using a table of values, those would be the best numbers.
Use your circle card, and they work out because when you look at this, and we'll look at pi over 4 here. If I have 4 sine of 2 times pi over 4, what does that become?
You cancel the 2's out, and that's pi over 2. So sine of pi over 2, that's 1. And then 1 times 4 is 4, and that's
how we got that guy.
Okay?
So that's old school graphing situation.
Yeah. The other thing is if we graph this on our calculator, it's better to have it in radian mode because then you can zoom trig.
Right.
And it gives you a window from -2 pi to 2 pi. And so if you did that, keep in mind that compared to our previous graphs, this is going to be a lot taller and a lot skinnier.
Right.
And that didn't really come across here, which is fine because we labeled it all correctly.
Right.
That's what's going on.
All right, so let's dump this cat and look at the next one. So this time I've got cosine of theta over 3 times a negative 1/2. So my amplitude in this case is not negative 1/2. So
No,
help
it's not.
me. I will punch somebody.
Absolute value of negative 1/2 is positive 1/2.
Yeah.
And so remember, amplitude is a distance, so it's always positive. That negative is telling us we're reflecting across the
So we're going to go
x-axis.
down first instead of up.
Yeah.
Okay?
So B is what we get if we take the theta out. So that's 1 theta over 3. Take the theta out, and that's 1/3.
And so...
How do I divide by a fraction?
Oh, divide by a fraction. Well, you might have learned in 5th grade. Maybe 4th grade.
I'm from Texas. I think we learned in 6th grade.
6th grade, okay. Texas
Okay.
people. So you
Back in the
multiply
day.
by the reciprocal of the denominator.
Okay, so the reciprocal of 1/3 is
So this
3.
becomes 2 pi times 3, or 6 pi. Which, that means, instead of scrunchies, we're going to have stretchies.
Yeah, stretchies. Wow. Marker to the face.
Mark it
Again.
the first of many. You got out of the way last time.
What are we?
What do you know?
You know,
You don't have enough room?
this is not smart notebook, so you can't really do that.
Alright.
Just- Oh, see, mine is smart whenever I try to erase. Let's pick a different one. Okay, let's do this.
All right, there we go.
Okay.
So now instead of stopping at 2 pi or something like that, we're going all the way out to 6 pi and
And up and down to 1/2.
up only to 1/2. So now half of 6 pi, trick question, half of 6,
Is 3.
3. Good job.
Half of 3 pi.
3 pi over 2. So again, if you wanted to make a table of points, these are the points that you're going to put in. So that would be, what's that, 3 pi over 2.
4.5 pi. 4.5 pi, which is
That 7, 8, 9 pi over 2.
9 pi over 2. So I'm happy with you labeling half of the tick marks. Like, I really want the 3 pi there, but these other two, not as picky about.
Right.
But if you're doing a table of values, you need
You
to
have
know what
to
those
have them,
are.
yeah.
So it's good practice.
It is good practice. Now, so when you graph this guy, it follows the cosine rule, which means we start out already up or down.
Yeah.
And in this case,
It's negative.
that negative guy right there means we're going to start down here. to
Start at the
-1/2.
bottom, and now we're here.
And then boom, and then boom, and then boom, and then boom.
Yeah.
Okay. And then going the other way. So here you got your sine curve. I feel like my marker's
Your
just a
cosine
slight
curve.
cosine curve.
It's maybe a skosh off. But it looks good. You did great.
There you go.
Wonderful looking cosine curve.
It's pretty good looking. Pretty brilliant, actually.
Now, if we graphed these in the same window on our calculator, comparatively, this one would go up a very small amount and down a very small amount and would be very wide.
Be really stretched out really long.
Yeah, so.
And then this guy is gonna be all.
Right.
So,
Comparatively.
yeah, if you put them on the same window.
Yeah.
Okay. Ready?
Yeah.
Oh my good heavens to Murgatroyd. 2 sine theta plus uno.
Now, keep in mind there's no parentheses here, so that plus 1 is like a D in our original thing that we have. So our amplitude is 2, our period is 2 pi over 1, which is 2 pi.
Hey, this is going to do the exact same thing as always, except
we're shifting everything up 1. So this is where we find out how we do things differently. Because what I do, whenever I graph this, is I say I'm going to go up to 1, and I'm going to make myself a little dotted line.
Brilliant
this
idea.
is not an asymptote line.
no,
Okay?
this is your middle of the road line right
Because
here.
we used that word oscillate earlier. Normally we are oscillating around the x-axis, but we just shifted up 1, so we need to oscillate around 1.
Y equals 1.
Yeah, y equals 1 instead of the x-axis.
Right. But now all the same things happen that we did before, except instead of being on the x-axis, we're on the line y equals 1.
Right, so now we're going, our amplitude is 2, so from 1, we have to go up 2.
But this is sine, okay?
And
So
down 2.
right, so since we've got the sine, we're actually going to start our 0 right here
In the middle.
in the middle.
Yeah, we
And,
need to
and
go
we
out the
still
middle.
can go out to 2 pi.
Right,
So we still have pi. We still have these two guys.
Right.
So now I'm up to 3,
right,
and now I'm back down
in the middle.
in the middle, and then I'm now one full amplitude below,
So that's at -1.
and then back to the middle. So that's how that guy looks, and I can do the same thing on the other side.
Right,
So I'm going to go down,
and then middle,
and then middle,
and then top, and then
and then middle.
it's a pattern. And then you just connect your curves. There you
Bingo,
go.
bango, bongo. That
Yep.
looks great.
And if that's really tricky for you, you could always sit here and graph 2 sine theta, and then just move all your points
Move it,
up
yeah,
1.
move them all up 1.
And that would
Which
work
will
as
only
well.
take about another half a second,
Yeah,
actually.
whichever
Yeah.
way makes you more
Now this
comfortable.
one's a little bit more tricky down here. We've got some issues,
Yes.
but not bad issues, just unique.
First
So
off, what does that even mean? -2 pi over 3?
that means that we're going to have an actual movement to the right of 2 pi over 3
Because
units.
it's the super secret opposite
Super
side.
secret opposite, yes.
All right, so the amplitude is +1, the period is 2 pi, but we're moving everything to the right 2 pi. So when we graph this, instead of having 0 be our starting point, we're saying that 2 pi over 3 is our starting point. And this makes things a little tricky because of the fact that we've got fractions, basically.
Right.
Because we need to figure out what is this point out here supposed to be. It's not 2 pi because we moved over 2 pi over 3. It's
Right.
got to be 2 pi over 3
Plus
plus 2
2
pi.
pi. So you got to run and do a little bit of quick math and add your fractions up.
So I want a 3 on the bottom, which puts a 6 on the top. 2 pi plus 6 pi is
8 pi's.
over 3.
So that's where we're actually going to stop. We're going to start at 2 pi over 3 because of the phase shift.
Right.
We're going to stop now at 8 pi over 3 because of the phase shift.
Right, and you have -1 and 1.
Yep. Now, divide this into half and then halfsies.
And to do that, if we're talking about the midpoint of 2 pi over 3 and 8 pi over 3, that's like taking an average. You add them together, which is 10 pi over 3, and then divide by 2,
5 pi over 3.
which is 5 pi over 3. And then if you were plugging points in, we could figure out what that is as
We
well.
just take the average of those two guys.
So
which
that's
would be-
7 pi over 6.
Yep.
And average of those two is 13 pi over 6.
I think so.
Which is not on the unit circle because
No.
that's more than 2 revolutions around, so
Right.
you have to subtract 2 pi first.
Yeah, you're going to have to do some math.
So,
But it follows all the same rules that the cosine graph originally follows. So
negative
So
cosine.
where we start is we start at the 2 pi over 3. And if we started at 1 before, the negative in front means we start down here now
At -1.
at
yeah.
-1. So then I follow my pattern. And it looks like this.
Yeah. Go ahead and connect them,
So,
and then let's deal with the other period, which is, it could be tricky. Like the first part was tricky, granted, but how do we figure out how to go to the left?
right.
This is how I thought of it. Between these two things, how far apart are those?
Those would be 3 pi over 3 units apart.
Okay, so if I take 2 pi over 3 and I subtract 3 pi over 3, what do I get?
That would be negative 1 pi over 3.
Okay, negative 1 pi over 3. So over here, negative pi over 3.
Is my starter.
Yeah.
Or is my next
Is
spot.
my next tick mark. Okay,
Gotcha.
which actually I have like a halfway point. Okay, because I started, I ended, and here's my halfway. Okay, so this is my halfway.
Right.
And then we'd subtract 3 pi over 3 again.
Which would be 4 pi over 3.
Negative.
Negativo 4 pi over 3. That's my end. So my graph will be done at 4 pi over 3. Now, this is really crazy stuff, so it may be that you have to watch this particular part a couple of times. And actually, a good idea is to practice. Can you reproduce this graph
Yeah, can you
on
do
your
it?
own? This
Yeah,
exact
on
same
your own.
one on your own.
Right. Well, you kept going a little bit there on the end.
Feel like that's, shouldn't that not be there?
Oh yeah, you're right.
Yeah.
That can happen sometimes.
There we go. So we're off just a skosh right there at that one spot. No, yeah, there you go. There you go. There you go. Good hands. Good hands.
Okay, so ignore.
So let's go over the actual line.
Oh,
How about that? So
there we go. That's a really easy thing to have happen.
as evidenced by
As
one of the
evidence,
world's
yeah.
greatest
This is my
precalculus
fourth time today graphing this, and that's
So-
the first time I did that. So, incidentally,
Good cover, good cover.
right here, this mark that we made, that's not at 0, 0.
No.
We'd actually figure out if we did some math. I believe that that's at pi over 6. And if you look, like, we could also think of this as a negative sine curve that's been shifted to the right, pi over 6.
Yeah, you could do that too, because sine and cosine are just
Related,
phase
yeah.
shift related.
Yeah. Next one. And now I
good
I
heavens,
just
what's
started
going
this
on?
off and said if you wanted to do it, you can. But we need to talk about, because here's our standard form. Okay, here's what we're pointing out on this. If I look in the parentheses here, I've got this double parentheses thing, and x does not have a number right in front of it.
It's got a 1. It has a number 1.
It has a 1. Okay, but here, this is 1/3 theta plus 5 pi over 6. And we can't have that. Like, our phase shift,
So I picked
I
up
don't
a
know what
marker
just
and put it
happened.
down.
Okay.
So-
our phase shift here is not left 5 pi over 6.
No.
Okay,
You've
because
got to pull the
it doesn't fit
1/3
this.
out first.
So let's talk about how to do that.
So when you pull the 1/3, remember you're actually doing divisione.
Yes.
So when I pull that 1/3 out, I end up with my theta here, which now matches what I've got up there. But instead of 5 over 6 now, when you divide by 1/3, you're actually multiplying the denominator by 3.
Right.
So this is going to be 5 pi over 18.
No, you're multiplying by 3. You're saying 5 pi
No,
over 6. You're
Divided
dividing
by
by
1/3.
1/3.
which is multiplying by 3. That's what I said. So I wrote down the 5 pi over 18 just to double check you and make sure that you were paying attention.
Thanks.
And you were. Excellent job. So
the 3
it's going to actually
stands
be
off.
15 pi over 6. But we don't leave it like that because 15 pi over 6 is a little weird.
Yeah.
And
We would
so,
reduce to 5 pi over
Yeah.
3. Okay, and that may seem a little tricky, but think about what we used to do back in the day when we had like 3x squared plus 18, and we said, let's factor this. We said, okay, I'm going to take out a 3, that gives me x squared plus 6. Okay, what did we do? We did 18 divided by 3, and that's how
Right.
we got that 6.
so you
here-
should be able to send that 1/3 back in there and get the same number that you started at.
And we don't. 3 times 3 is 9. So that should be 2 on the bottom.
2. Just following your lead.
Yeah.
We do know what we're doing. We are trained monkeys.
Let's try it on this one. Let's factor the 2 out on the second one.
5 pi over 12.
Because we're dividing this by
the 2.
So that's like multiplying by a half.
Right.
And so there's nothing to cancel out, so it's 5 pi over 12. And then on both of these, once it's actually factored, we can talk about all kinds of stuff. Like on the second one, we're vertically shifting 4. Our amplitude is not shifting. We're stretching vertically 4. Our amplitude is 4. It's a positive sign. We're horizontally shrinking by a half. So our period is pi, 2 pi over 2, which is pi.
Right.
We're moving to the right, 5 pi over 12. We're moving down 2. Like that's going to be like 2 questions probably at the end of the section that might make us do all those things at once.
Right.
Okay, most of the time it's just going to be a couple things that they show you.
This is the big granddaddy.
Yeah. So this
see
is
if you
like,
can't work it out.
See if you can. See, it'll be fun to see. Like it's fun to have to mess with it. It's almost like a puzzle.
It is like a puzzle. It's not almost to it. It is a puzzle.
Okay, it is a puzzle.
Yeah.
So that's it.